All right, welcome back. If you're a GCSE Edexcel psychology student gearing up for Paper 2, you are in exactly the right place. Today's explainer is a total masterclass in experimental designs. We're going to break down how psychologists actually set up their research, weigh the pros and cons of different methods, and, most importantly, see how one simple choice by a researcher can literally make or break an entire experiment. Let's get right into it.
So here's our game plan for this revision session. We'll start with a quick refresh on variables, then tackle the big three: independent groups, repeated measures, and matched pairs designs. Finally, we'll put all that knowledge to the test with some exam-style practice.
Okay, part 1, variables and psychology experiments.
Now, before we even think about designing an experiment, we have to know our tools, right? You already know the basics. The independent variable, or IV, is our cause. It's the thing we actively manipulate. The dependent variable, the DV, is the effect, the data we're measuring at the end. But then we have the extraneous variables, the EVs. These are those sneaky, annoying background factors that we have to tightly control before they totally derail our beautifully planned study.
And that brings us to a massive headache for psychologists: participant variables. Basically, individual differences. We are all wonderfully unique, which is great for humanity, but, kind of terrible for controlled experiments. Take a memory test, for instance. If someone naturally has a photographic memory or just a really stellar short-term memory, that's a huge participant variable we have to deal with.
So ask yourselves this: if we just randomly assign people to groups, couldn't we accidentally put all the memory geniuses into condition 1 and the more forgetful folks into condition 2? Condition 1 would definitely look like it performed better, but it wasn't our independent variable doing the work. It was just their natural talent. Haven't we literally just ruined our own experiment? Yep, and that's exactly why controlling these variables is absolutely crucial.
Which leads us to section 2, independent groups design.
In an independent groups design, it's pretty straightforward. You take your sample, chop it right down the middle, maybe using a random computer generator, and give each group a totally different task. Group 1 only experiences condition A. Group 2 only experiences condition B. At the end of the day, you just compare the results, your dependent variable, between the two completely separate groups. Now, the trade-off here is fascinating. Its biggest strength is speed. It is so quick and easy. Plus, both groups get the exact same stimuli, like the exact same list of words, which avoids the bias of one list being easier than another. But that speed comes at a cost. Remember those participant variables we just talked about? Because you're using completely different people, your data is super vulnerable to being skewed by individual differences. Oh, and you also have to watch out for investigator bias, especially if you aren't strictly using random allocation.
All right, moving on to section 3, repeated measures design.
So if participant variables are the big problem, this design is the ultimate solution. In repeated measures, everybody does everything. You take your whole sample, they all do condition A. Then, that exact same group goes and does condition B. We aren't comparing group 1 to group 2 anymore. We are comparing a person's performance against themselves. But here's the catch. While we absolutely crush the issue of individual differences, we invite a brand new villain into the mix: order effects. Think about it. Because the same person is doing the test twice, they might do better the second time just because they've had practice. Or they might do way worse because they're tired and fatigued. Also, you can't reuse the same word list twice, so you have to introduce new stimuli, which begs the question, what if the second word list was just naturally easier? Well, here is the absolute genius workaround. To fight off those order effects, we split the group and use what's called A-B counterbalancing. Group 1 does condition A, then B. Group 2 does condition B, then A. It's so elegant because it neatly cancels out the fatigue or practice effects. Everyone still completes all the conditions, but by flipping the order, if Group 1 is getting exhausted during condition B, Group 2 is getting equally exhausted during condition A. Everything perfectly balances out across the whole experiment. Okay, section 4, matched pairs design. Sometimes you really just need a middle ground, and that is where matched pairs comes in. You pair a participant in Group 1 with a highly similar twin in Group 2 based strictly on relevant criteria. And I mean relevant. There is 0 point matching people on gender for a memory test unless gender actually impacts memory, right? You carefully evaluate your participants, pair them up based on age, experience, or whatever matters for your specific study, and then one twin goes to Group 1 and the other goes to Group 2.
It sounds great, doesn't it? It beautifully minimizes those pesky participant variables, and because they only do one condition, bam, no order effects. But there's a huge weakness. It is incredibly difficult, sometimes literally impossible to match humans perfectly. Sure, you match their age and gender, but what about their sleep quality last night, their diet, their hidden natural talents? There's always going to be some participant variability remaining. Plus, it is so time-consuming that it's frankly not always suitable. Sometimes you're better off just going back to a repeated measures design.
All right, Section 5, putting knowledge into practice. Let's see how this works in an exam scenario.
Let's step into the shoes of the researcher. Imagine you are testing this exact hypothesis. How would you structure your participants for each of the 3 designs? Well, if you used independent groups, you'd have one group of 20 listening to Mozart and a completely separate group of 20 in silence. For repeated measures, all 40 participants would do both trials, learning one list to Mozart and another list in silence. And matched pairs? You'd use 2 separate groups, but you'd match them first, like making sure 2 16-year-old females with the exact same target grades were split, one in the Mozart room and the other in the silent room. Let's do a rapid-fire quiz for your final extension challenge. You want to test if drinking coffee increases concentration compared to drinking water, using 20 participants. Think about what we've learned. Independent measures. Easy. 10 drink-only coffee, 10 drink-only water. Quick and easy, but maybe the coffee group just naturally has better focus anyway. What about repeated measures? All 20 drink coffee on day 1 and water on day 2. No individual differences to worry about, but you had better use ABA counterbalancing so they aren't just completely exhausted for the second test.
So as you prep for paper 2, remember this. Experimental design is not just a list of steps to memorize. It is literally about outsmarting the hidden variables that are constantly trying to ruin your data. Master these 3 methods, know their trade-offs, and you'll be fully prepared to think like a true psychologist on exam day. I'll leave you to ponder this final thought. How easily could a totally brilliant, groundbreaking psychological theory be completely destroyed just because the researcher chose the wrong design? Thanks for joining me in this explainer, and happy revising.